Well, calculate the total number of electrons present in 1 mole of methane. What is methane? Methane is CH4. Carbon contains 6 electrons and hydrogen contains 1 each. So I have 10 electrons. Okay. So every molecule of methane contains 10 electrons. Why exactly? Carbon personally contains 6 electrons and each hydrogen contains 1. So if we add up CH4, that makes it 6 plus 1 plus 1 plus 1 plus 1, 10 electrons. Perfect. So 1 mole of methane. Now 1 molecule of methane contains 10 electron. So 1 mole methane molecules will contain how many electrons? Well, that would be 10 into Avogadro's number, which is 10 into 6.023 into 10 raised to 23, which is 6.023 into 10 raised to 24 electrons. Wonderful. That's it. Lovely. Find A, the total number, and B, the total mass of neutrons in 7 milligrams of C14. Assume that mass of a neutron is so much. Oh my God, what do? We solve. And how exactly? See, we have 7 milligrams of C14. Now, what is C14? C14 represents, it has 6 protons. Yes. How do I know this? You have to muck this up, that carbon contains 6 protons, or anything that contains 6 protons in the nucleus is called carbon. You have to remember this as a student of chemistry. This data will not be given to you every time. Anything with atomic number 6 is called carbon. And 14 is atomic mass number, so neutron plus proton is 14, but protons is 6. Therefore, number of neutrons is 14 minus 6, which is 8. So 1 atom of carbon contains 8 neutrons. 8, right? Now I have 7 milligrams of C14. How do I find this number and mass? I need to first find number of moles, right? So number of moles of C14 atoms. Now moles is mass by atomic mass. Yes. So moles will be mass. Mass is 7 milligrams divided by atomic mass. Now atomic mass 14. It is given clearly, so it is 14 grams per mole. That makes it 0.5 millimole. Why milli? Because milligrams will give you millimoles. Milli just means multiplied by 10 raised to minus 3, nothing else. Don't worry about it too much. So I have 0.5 millimoles, which means 0.5 into 10 raised to minus 3 moles of C14 atoms. So I have got number of C14 atoms. But is this what I need? No. I need number of neutrons. Okay. Now, therefore, number of moles of neutrons is how much? It is something like, if I have one truck, and one special truck which contains 8 wheels, a giant truck which contains 8 wheels. Fine. So if I have 10 trucks, how many wheels would I have? Well, just multiply 10 by 8, because every truck contains 8 wheels. So if you have 10 trucks, you have 10 into 8, that means 80 wheels. In the same fashion, if I have one atom that contains 8 neutrons, if I have so many atoms, then number of neutrons will be 8. 8 is number of neutrons present in one atom multiplied by number of moles of atoms, that is 4 millimoles of neutrons. But they have wanted not the moles but number, and I use the formula N is Avogadro's number into number of moles. Number of atoms or molecules is Avogadro's number into number of moles of that substance. Avogadro's number as a unit per mole, and this becomes mole. They can cancel away. How much do I get? I get, well, let's multiply by 4. So 23 4s are 92. So 24.092 into 10 raised to 20. Or I could say this would be 2.04. No, I'm sorry. That would be 2.4. 2.4092 into 10 raised to 21 neutrons. We should write in scientific notation. This would be the number of neutrons, right? And they are now expecting the mass of a neutron also. They have given mass of neutron and they expect the total mass. How do I calculate that? Well, I don't think that's very difficult, because if I've got the number of neutrons, I can multiply this by mass of a neutron. Yes. What would I get? Mass of neutrons. There are two ways I can do this. I'm doing it by the more stupid way. 2.4092 into 10 raised to 21 neutrons. And how many neutrons do I have? Yeah, what is the mass of a neutron? 1.675 into 10 raised to minus 27 kg. Fanciful. Let us multiply this and get a really dirty number, and that would be the answer. That is one method of doing that. You can calculate that and see this is the answer. This is number of neutrons. We have got a number 2.408, and this is what we did by hand calculations, 2.409. That is more accurate. This is what I get into 10 to 21 neutrons. What about the mass? Well, mass comes out to be this much. If you multiply that number, you get this ugly thing. And can I just stress that you can do it? I told you this is a stupid way of doing it. I can give you a simpler method also. What? See, mass number is 14. That means mass of one C14 atom is 14 AMU, right? Mass is 14 AMU, and this mass is because of neutrons, protons and electrons. Electrons are negligible, so essentially this is mass of neutrons plus protons. If I may be so bold and a little approximate, I say it is a little approximate, but if I may be so bold, I could say that, see, out of 14 AMU, mass of neutrons is 8, because we calculated it as 6 protons and 8 neutrons. So 14 AMU mass of C14 contains the 14 AMU mass. If you take of C14, one atom of Cu14, 14 AMU its mass, it contains 8 AMU neutrons. That means, therefore, 14 grams of C14 contains 8 grams neutrons, right? That means that if I have 7 milligrams of C14, it contains 7 milligrams into 8 upon 14 of neutrons. If you take grams, grams will cancel off. That's it, yeah. So that is 4 milligrams of neutrons. Of course, this is approximate answer. You can cross-check very easily. 4 milligrams of neutrons should be there. An accurate answer would be obtained if you multiply that number of neutrons by mass of each neutron, and then you get 4.035, whatever. That's as close as it gets. Find the total number and total mass of protons in 34 milligrams of ammonia at STP. Will the answer change if the temperature and pressure are changed? Well, let's take a look. Now we have to find the number and total mass of protons in 34 milligrams. So what is given? I am given that mass of ammonia is 34 milligrams. Now NH3, nitrogen is 14, hydrogen is 1. So ammonia's molar mass would be 14 plus 1 into 3, that is 17 grams per mole. This is molar mass of ammonia. Yes. Can I find the number of moles of ammonia? Yes. So moles of ammonia molecules is this is by formula it would be mass by molar mass, which is 34 milligrams divided by 17 grams per mole. Grams cancels away, that makes it 2 millimoles. Please note, milli does not get cancelled with grams. Milli simply means multiplied by 10 to the minus 3 and nothing else. That stays. So I have 2 millimoles of ammonia. And one nitrogen atom contains 7 protons. Why? That is the definition of nitrogen atom. Any nucleus that contains 7 protons would be called nitrogen. From periodic table we know that. Otherwise you should know that. H atom contains 1 proton. So NH3 contains 7 plus 1 into 3, that means 10 protons. Wow. So I have 20 millimoles of NH3 molecules, and this implies 2 into 10 millimoles of protons. So I have 20 millimoles of protons present in ammonia. Now I have to find number and I have to find mass. How can I find the number? Number is quite simple. I can say number of protons, N, is moles into Avogadro's number. Moles is 2, 20 millimoles. So many moles into 6.023 into 10 raised to 23 per mole. Well, let's multiply that. What would that give? 12046. And what about the decimal 120? That means 1.2 into 10 raised to 22 protons. So my dear, this is the number of protons. Just multiply and get that number. Anything else? B part, total mass of protons. How do I get the mass of protons? Well, that's very simple again. See, I'll use the space for further calculations. Now, nitrogen atoms, if you see, and a hydrogen atom is 1, 1. Mass of hydrogen is same as mass of a proton. Electrons have negligible mass. And whatever is the mass of nitrogen, if nitrogen has a mass of 14, then out of that protons have a mass of 7 AMU, and remaining 7 AMU goes for the mass of neutrons approximately. Very, very approximate. Very closely, it is reasonably accurate, but a little approximate. So, mass of protons in ammonia is 10 AMU. One molecule of ammonia. Why? 7 AMU is the mass of protons in nitrogen, 1 AMU in each hydrogen. There are 3 hydrogens, so 7 plus 3, 10 AMU. Okay. Therefore, 10 AMU. Now, 1 AMU per particle is equal to 1 gram per mole by definition. So, therefore, 10 AMU per molecule is equal to 10 grams per mole of ammonia molecules. If I take ammonia molecules, 1 mole of ammonia molecule contains 10 grams of protons. But do I have the number of moles of ammonia molecules? Yes, I have that. It is how much? 2 millimoles. So therefore, 1 mole of ammonia molecule contains 10 grams of proton, so 2 millimoles of ammonia molecules multiplies by 10 grams of protons per mole of ammonia molecules. I have written units very clearly so that you can just cancel this. So I get how much? This is 20 milligrams of protons, or 2 into 10 raised to minus how much? If you would just want to calculate in kilograms, then milligram is 10 raised to minus 6 kilograms, so 2 into 10 raised to minus 5 kilograms of protons. Okay, so much so? Yes, so much so. If you don't want this, then you use the accurate mass of protons and do the multiplication, you will get very nearly the same number. See, if you see the mass of protons, this is what you get. And will the answer change if temperature and pressure are changed? The question is, I'm sorry, it will not change. Why? Because mass is independent of temperature and pressure. So, no. You may say that the calculator answer is not exactly 2, but it is 2.018. How do I get this 2.018? I can tell you that also. Just look. Now, if you want to be more accurate, I can tell you a method. Mass of one proton is 1.0073 AMU accurately, more accurately rather. We approximated it as 1 AMU. But actually mass of one proton is not 1 but 1.0073. If you want to take the tail of 0073 and drag it along, you can get a more accurate answer. How exactly? I'll show you. So let me recalculate in a more accurate fashion. Wherever we used 1, now we had 2 millimoles. 2 millimoles of ammonia will correspond to 2 into 10 into 1.0073 milligrams of ammonia. So our answer gets multiplied by 1.0073. So that stupid 0073 gives me additional glamour. So how much that comes out to be? This is 2.0146 into 10 raised to minus 5 kg. So many grams, if you convert to kg, this is what you would get. So approximate answer was 2 into 10 raised to minus 5 kg. You want to come more close in decimals, 2.0146, 2.01 ting ting 38. That's close. It's a more accurate answer. If you want, you can use this result, but for this, you have to learn that mass of one proton accurately is 1.0073 AMU.